Hello friends, today we are here to discuss exercise 1.1 question number 2. What is this question now? It is in front of you. Show that any positive odd integer, underline this word children, positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5, where q is some integer. Okay, so now the solution is, let a be any positive integer, okay, and b is equals to 6. Why I am taking over here b is equals to 6? Because here it is given in the question that positive odd integer is of the form 6q plus 1. Okay, that's why I am taking over here b is equals to 6. Then by Euclid's algorithm, a is equals to 6q plus r. Now children, I said in the previous video also, whenever you are hearing this word Euclid's algorithm or Euclid's lemma, the first thing you should get in your mind is a is equals to bq plus r. So here children, at the place of b, what is given over here? 6q. So a is equals to 6q plus r. For some integer, q is greater than or equals to 0. Okay, obviously the q should be greater than or equals to 0, and r should be, the remainder should be greater than or equals to 0 but less than 6, because here remainder should be less than the divisor. So the divisor is given over here 6. So r should be greater than or equals to 0 but less than 6. So r is equals to, what are the cases then? If it is less than 6, then what are the possible cases? 0, 1, 2, 3, 4 and 5. These are the possible cases for remainder. Okay, then a can be, as we have taken a can be any positive odd integer. No, sorry, we have taken any positive integer. Okay, so a can be 6q plus r, can be of the form 6q plus r. So at the place of r, we have to substitute these values, that is 0, 1, 2, 3, 4 and 5. So a can be, first we are substituting at the place of r, first we are substituting 0. So a can be 6q plus 0, then a can be 6q plus 1, then a can be 6q plus 2, then a can be 6q plus 3, then a can be 6q plus 4, then a can be 6q plus 5. Just we have substituted the values of r here, that is 0, 1, 2, 3, 4, 5. Now after that it is given that, however, since a is odd, here it is given now, show that any positive odd integer. Okay, so since a is odd, a cannot be, what a cannot be? 6q plus 0, because we want an odd integer. Okay, so a cannot be 6q plus 0, a cannot be 6q plus 2, or a cannot be 6q plus 4, because they are divisible by 2. Okay, 0, 2 and 4, okay, they are divisible by 2. So since a is odd, a cannot be these three values. Then any odd integer is of the form a is equals to 6q plus 1, a is equals to 6q plus 3 and a is equals to 6q plus 5. Odd integers. So that's why we have taken the numbers 6q plus 1, 6q plus 3 and 6q plus 5. That only we have to prove. See now again, show that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So,